Gustard have made an R2R DAC with a built-in streamer. Let's check it out. Now, I'm not completely familiar with Gustard. I've seen them mentioned on forums such as HiFi, and it always struck me that their DACs tended to aim towards measurement accuracy over all else, to the point that I believe Golden Sound observed that their measurement accuracy was so high that actually in music playback they were more likely to distort as a result of the setup of their digital filter. So that's pretty crazy. I mean, preferring the accuracy of test tones over musical playback is crazy, but that's how far we've gone. So I was actually very surprised to find out that Gustard had made the R26 an R2R DAC. And not only that, it has a built-in streamer, something we'll take a look at later. Now, for those of you unfamiliar what an R2R DAC is, about 20 odd years ago, it was common if you were buying a high-end DAC to get an R2R DAC. And they used chips from, say, Analog Devices, from Burr Brown, which is now owned by Texas Instruments, and the like. And they used a series of laser trim resistors to reconstruct the analog signal from the digital signal. And the R2R stands for resistor, and 2R, resistor of double the value. And these resistor pairs are set up to take the, you could say, the digital word and then reconstruct the voltage output for that individual digital word, and doing that at, say, 44,100 times a second, that gives you your CD quality audio. The limitations of these DACs is that they were limited fairly to 16 or 20 bits and 48 kilohertz output. It was possible to get higher than that, but it was only later on. Now, with high res becoming a big thing, that pushed them aside into the better measuring, but some people felt not as good sounding Sigma Delta DACs, such as we get from ESS Tech and AKM nowadays. So with those old DACs out of the way, what if you wanted to make an R2R DAC? The way now is, because there are no R2R chips, unless you can find some old PCM 1704 chips floating around for great amounts of money, is to build your own R2R DAC using regular resistors. And to give an example that's easy to see, this is a Socris DIY board, which I've had for a while, and you can see the rows of resistors there for each channel, which is the reconstruction DAC there, and the black squares or black rectangles are the switches that switch them in and out. Now, this is the basic format for R2R DACs these days. But the problem with this kind of setup is the most accurate resistor you can get is like a 1 in 10,000 accuracy resistor, which sounds great, but you need 1 in 65,536 accuracy to get 16-bit. And 24-bit, we're getting into the millions there. No, it's just not going to happen. So, I mean, DACs nowadays can only really realistically do about 20-bit, or maybe if you're super lucky and super clever, 21 bits of audio accuracy anyway. But still, it kind of stacks everything against you if you're trying to make a good R2R DAC. Now, if we've seen in DACs such as, say, the Holo DACs, they'll use multiple boards and multiple sets of resistors, and as well as FPGA correction and other things to deal with the issues of R2R ladder accuracy. Now, we don't have anything quite as sophisticated in the R26, but what we're going to do today is we're going to take a look not only at the features that it has, including the streamer and the interesting menu system it has for setting that all up, but we're also going to take a look inside the DAC at the different components and how sophisticated it is. Now, if you've seen my videos before, then you can compare it to some of the other things I've opened up and take a look inside of. So let's get started and take a look at the back of the DAC and have a look at some of the features that it has. To start with, you have your standard power input. Of course, the power supply is entirely inside. And the voltage switch, you have to switch 2 switches at the same time to switch between 115 and 230 volts. And which is a little bit unusual, but that's what it is. There are 2 transformers inside, which we'll see when we take a look inside the DAC as well. Now, the outputs, of course, are fairly straightforward. You have your standard balanced 3-pin XLR outputs and your single-ended RCA outputs. We'll talk about a little bit more about those later, but probably the confusing thing is that the outputs look very similar to the digital inputs, even though this is analog and this is digital and completely different. They use the same kinds of connectors, which is handy in some ways and a problem in others, but
You have your standard, well, coaxial digital input and the balanced version of that, which is AES EBU, although it's probably just regular AES. I don't think it's got the full feature set of the Pro Audio version, but that's kind of neither here nor there. And you have the optical version, which you have optical input. Now, one of the unusual things for these inputs is you have a 10 megahertz input, and that's for an external clock. Now, digital to analog converters use a clock. You have to keep everything, the timing correct. And the quality of these clocks determines a lot about the quality of the DAC. And some people have been using external clocks. This is something that usually is used in pro audio, not an external clock, but synchronized clock. An external clock uses a higher quality, more stable clock, and the clock signal is input separately. And so this is an option in this DAC, and we also saw it in the Audio GD DACs, and some other DACs have it. Now, we also have your standard USB input, and we have, this I believe is not electrically isolated like the high quality USB inputs in, say, Audio GD and in other manufacturers. So it's a little bit of a disadvantage, which I found in when we'll talk about when I do the sound impressions. Now, unusually, of course, we have the LAN input, so local area network input. So this allows you to connect it to a network and have network streaming directly to it. One of the weird things about this input is that the lights are not connected on here, so you don't see the normal flash when there's a network activity. It may seem that it's not like it's not working at all, but it's simply that the lights must not be connected. Now, we also have I2S. Now, this is not a HDMI input, even though it has a HDMI socket. It's used for connecting, normally like coaxial and AES EBU. The data and the clock signal are sent together. But this separates out the data and clock signals into separate wires, and it's normally used inside a DAC after, coaxial digital or whatever is converted into an I2S signal which is sent to the DAC. But this allows a direct I2S connection, and some people believe it can, improve the sound quality. But it's one of those complex things, but it's available there. Now, Gustard has their own pinout for it. There's no particular standard, unlike USB coax and other things, and that makes it a little bit tricky to set up sometimes, but again, something I'll talk about later. Lastly, we have this USB-C port, and that's used for updating the programming of the inbuilt streamer and the firmware updates. So that's something you can do, and they've been updating the firmware recently, and I've been using the most recent firmware as of the date of the publication of this video, unless they suddenly updated it on the same day. So that's something to consider. And it also has a Bluetooth input, which is common on Chinese digital to analog converters, and that's there for convenience. Obviously lossy, but something that's there if you desire to use it. So with that all being said, let's take a look at the menu system available for this DAC. Okay, going through the controls, you have, of course, the center button here, which will allow you to cycle through the inputs. There we have AES, I2S, USB, optical, Bluetooth, and LAN. Now, this, because it has to boot up the internal streamer, does take some time to kick in. So if I was using Roon, I had to wait a minute before it would actually appear in Roon. You also have the digital volume control here, and I'll talk about that in just a bit because I want to get into the menu. Now, to get into the menu, you can either use the remote control or long press the center button and then control it using the volume wheel and the center button, but I'll use the remote so that you don't have to see my finger the whole time in front of the camera. Now, the first of the options on here at the top is called a PCM filter. Now, there you have three options from fast, which is probably I'm guessing some kind of linear phase filter, mid, which it doesn't specify what it is, and slow, which is probably minimum phase. Now, some people notice a difference between different filter types, and some people don't. You can just play around with it and see if you do. But if you want to, say, use external upsampling, say with HQ Player or Roon or whatever, then what you can do is actually turn off the digital filter, which is to turn on PCM non-oversampling, which is kind of counterintuitive. It should say PCM filter on off, but yeah. Anyway, that if you turn that on, it actually disables the internal FIR filter, which is how they describe it. Now, if you know what digital filters are, you'll understand what that means. If you don't worry. However, if you do turn that on, then the volume control is locked because it's sending the PCM data straight through to the R2R digital ladders. So probably also if you're using something like HQ Player, that may have a higher quality digital volume control anyway. Rather than truncating the data, it may use noise shaping or something else. Anyway, the third option is DSD Direct, which I used when I was evaluating DSD. And again, same thing, if you turn it on, it sends DSD Direct into, well, I don't quite understand what it can actually do to the DSD data, whether it converts it or what exactly goes on. It's not quite clear, but any kind of a change to DSD, the only kind of thing it could be doing would be to attenuate excessive high frequency noise, but it doesn't really make it clear in the manual what it's doing. Now, attenuation means the volume control. If you have that on, now if I have that on and go out, I can actually change the volume down to it was about minus 90 dB. So let's see, it actually goes through all the way down to, now it was minus 90 if I recall. Indeed, minus 90 dB. Now, however, the manual states that the first minus 30 dB from 0 is an analog attenuator in there. Now, I'm not sure what that is. I'd have to look inside the DAC to find out. But beyond that, if you want to go down to, it says if you want to go down to, say, minus 40 dB, say if you're using, say, active speakers or some very sensitive system, then it means you only get 10 dB of digital attenuation. Now, digital attenuation basically cuts bits off the data, and that's bad for R2R DACs. And this is something we saw in the Cayenne RU6 review. That's the dongle DAC that uses R2R ladders. They had to build a custom volume control to fit in it, because only an analog volume control wouldn't basically wreck the sound quality. So if you have, say, minus 40 dB of digital attenuation would sound terrible. Having only minus 10 dB plus, the minus 30 dB of analog volume control shouldn't be such a problem. But obviously down to minus 90 dB, that's going to be very poor for this kind of DAC in using it as a volume control. So I would probably, if you're going to use some attenuation with it to kind of match the volume into a system, which I did for, say, kind of volume matching between DACs when I was listening, then that would be okay. But if you're going to go below minus 30 dB, I would avoid doing that with this DAC entirely. So it's just digital attenuation on R2R DACs is bad. So unless you can use noise shaping, which requires a lot more, heavy processing. But anyway, back to our list of things in this very tiny menu, which I can only actually read from the camera and not actually read from where I'm standing. You also have the ability to enable the external clock, which we saw the socket for on the back if you're going to use an external clock with this, which I didn't do. You also have the ability to invert the phase if necessary. If you have you can experiment with that and see if it makes the sound any different. Some music, I believe, had phase inversion. You may also have the situation where you're plugging this into the amp, which has the reversed polarity for the XLR inputs. So the normal XLR pin out is pin 2 hot, or pin 2 positive, basically, and pin 3 cold or minus, as we tend to think of it. Some Japanese amps had that reversed. You could reverse that. The other reason may be if you're using the I2S input and the I2S output of the device you have doesn't match the Gustard input, maybe the phase is reversed. Some I2S inputs have the channel reversed or the phase reversed. And there's not a consistent standard, so it makes it very tricky, and sometimes you may need to use that. Brightness, this display is really dim. I mean, if I put it's on auto now at its brightest because the room is bright. But if I turn it on to 1, well, you can see it's barely visible. And this is going up to a maximum of 8, and it's still really dim to the point that even at night with all the lights off, I find this level to be fine. So I think there may be a piece of kind of dark plastic in front of the display, and that's why it's so dark. But it's, quite dim, and even it dims itself slightly more until you start doing things such as adjusting the volume control, and then even then it's still pretty dark. So that's probably one small negative about it, and that's of course the fact that if you are, say, long-sighted, you're going to have trouble reading the menu without using glasses, or in this case I'm using the magnification of my camera. People have told me they like me showing the insides of components I review, so I'll give a quick overview of what is inside this R26. Now we have a pair of transformers, and they go into various power supplies, which I think are kind of around this area. Now it's a good idea when producing different voltages for, you have an analog section which will have higher voltage output than, say, the digital section, which will use much smaller voltages, and to separate those out so they don't interfere with each other, and that in turn reduces distortion. Now this is obviously not the most sophisticated device we've seen. I think Audio GD wins in that, and the amount of power supplies you have in one component, and then you have smaller stuff which is more minimal. This sits somewhere in the middle. Now after that we have this board in the middle, which I'll just tilt and show you in just a second, and that is the digital, I guess, control board. It has a streamer built in. It controls, you can see the ribbon cable to the front. It basically controls all the functions and has software, etc. And the inputs you can see are either on the board or we have the digital inputs here. And you can probably just see the traces coming in here to this connector, and the traces going out to the digital R2R ladder down the bottom here, and probably the middle is power supply for it. So if I tilt it slightly on its side, you can see there's a lot going on in there. I think it has its own FPGA or CPLD here. We have an XMOS processor. We have the Bluetooth processor. We have a whole bunch of other stuff going on. We have the micro SD card, which you can actually remove if you don't, update the programming via the USB-C socket. So it's actually, they're pretty good going that they've developed their own, digital control center for their DACs. And I think this is in the A26 as well. And that means they can update it with new features. And I believe I've seen people hack this to install things like Tidal Connect, which I don't think is or wasn't available. I can't remember. So do check out the features of this DAC. Will actually probably change after this video. And I remember that I just used Rune and HQ Player with it. I didn't use anything else. So I probably haven't covered quite everything in terms of usage. But anyway, we'll talk about that later. Now, once you have the output here, that goes into the R2R ladder board, and we have, and I counted the pairs, 96 pairs per side of resistors. So you have a resistor and it's half its value installed, all the way along this board, at least different levels for different volume outputs. And then the digital, what's called a word, which will be a series of what we call ones and zeros, but ons and offs, will be sent through this FPGA or CPLD into the resistor ladder, and the switches on the side here will switch in the resistors as required to give the required voltage output. Now you have obviously left and right channels, and then this goes out into the analog board. Now I've just unscrewed this because if you're wondering where the DSD is processed, it's not on the same board like you have, say, in Audio GD. It's actually under the board, and they showed a picture of this, and so you can actually see the same thing in the picture. This is the DSD ladder. Now, some documentation that says, the DSD is sent into the R2R ladder. That's not correct. This is not an R2R ladder. It's a DSD ladder, which is slightly different. And I'll carefully put that back as I don't want to damage anything. And this analog output, well, it seems to be a balanced stage. So you have, I guess, left and right channels, and you have 2 sections per channel, and that will be, the positive and the negative to give the balanced output. Some people have commented they've seen op amps in the middle here. Given the number of transistors in this circuit, I don't think these op amps are for the output. I think these are DC servos, which keep the circuit from outputting raw DC into the connection, which would be very bad. But they're commonly used for basically as DC servos. So they're not really used for amplification. They're used for a specific purpose to make the circuit work. And op amps seem to be the most optimum for that, rather than using a whole bunch of discrete components. And so I believe that there is essentially a discrete component output given the number of transistors. And then that's the balanced output and the single-ended output. I don't know for certain, but it could be that, given that I can't see any op amps in there, that the RCA circuit just takes half of this circuit and then the signal return is to ground. So I presume it uses half the circuit. I could be wrong. Without checking in detail, I don't know. Some amps will use other methods to produce the single-ended signal, and some will just use the most basic one. And on most kind of analog circuits that you see in DACs, it's very, very rare that you'd have a significant degradation on the single-ended output. Maybe a tiny bit, but usually not. So that's the inside of the R26, and now let's get on to the next part of the video where I talk about how it performed.
The difficulty when talking about the sound of a DAC such as the R26 is that in its price range and above, the differences between different digital converters can be very subtle and fairly minimal, and they're very dependent on the kind of music being played back, as well as the sensitivity of the listener, and to some degree, of course, the quality of the other components used, whether they be speakers or even high-end headphones. So in that, there are 2 aspects in which I can talk about the sound. The first is the level of detail. So that would be if I played back a high quality recording of instruments, say in a room which has some degree of echo, or say a concert hall, how much could I, for example, hear the amount of the sound echoing off, say, the other instruments or the walls and that kind of thing? How much of that kind of atmosphere comes through? Or if you're listening to a singer, how many of the subtleties of her voice and her performance in front of the microphone comes through. Or with instruments, maybe if you have something like a piano, when a note is hit, how well can you hear the decay of the notes? And as you get into better equipment, of course, this improves. The second aspect is, of course, well, I would call it the tuning of the DAC. Now, in a lot of people's minds, people think that the manufacturer should not tune the DAC. It should be set up to reproduce the music as accurately as possible. And while this is an understandable ideal, the reality is all the many components that make up devices such as the R26, each of them adds its own kind of distortion, and a lot of the work goes into optimizing that so that it has either a minimal effect or it has effect that is pleasant. So to some manufacturers prefer adding a little bit of harmonics in there, say even order harmonics, which you'll see if you see measurement graphs with the 1 kilohertz tone, you'll see sidebands at 2, 4, 8, 16 kilohertz. And a little bit of that is not necessarily a bad thing. Some manufacturers, we've seen SMSL, will actually have a setting to allow a little bit of that in or have it off altogether, so you can choose for yourself, which I think is a reasonable option. You also have third order harmonics, which of course multiples of 3. You can imagine what that looks like on a measurement graph. And there are other aspects too, which are often not shown in measurements, such as the crosstalk, and the shape of the crosstalk can decide how strongly different frequencies come through, as the crosstalk of course refers to how much of the left channel and the right channel bleed into each other. And by adjusting this, say, to a maybe slight V shape, you can give the impression of there being a larger sound stage. Now, of course, we know Gustard tends to go for accuracy first, sometimes to a fault, where even playing back music, it might actually distort, since that it is set up primarily for maximum measured performance with test tones. But with an R2R DAC, that's kind of impossible to have a super high performance in terms of measurements. Now, if we look at harmonics, in terms of measurements, they're considered distortion, but if you think that instruments themselves create music by inducing harmonic distortion in things like wood and metal, this is how music is produced essentially. And some harmonics may be added in by the mastering engineer, and of course, well, you have a choice whether it's added in by the manufacturer or not, which you might have, say, with a tube amp. So given those two things, detail and tuning, the Gustard itself, in terms of detail, I felt that it was about spot on for the kind of price range it's in. Now, I compared it directly to Schiit Audio's Yggdrasil, or what's called the OG now, what was previously called the Analog 2, and I felt that the Yggdrasil was resolving a slight bit more detail than the Gustard R26. Likewise, if I go into other DACs around that price range, such as the Chord Hugo 2, similar kind of result. And of course, if I go scaling up even further, then I could retrieve more detail from the music, and especially considering that things like the Chord DACs have their own headphone amp built in, which are also designed for extreme accuracy. Now, of course, I was limited to what amplifiers I have on hand. You can't see it necessarily on the desk, but I also have an Audio GD Master 9 under the desk. One of the comparisons I did, of course, was with the R27HE. Now, inside the R27HE is more or less Audio GD's R8 DAC. Now, that DAC on its own, not in a combined unit, costs about the same as the Gustard R26, and I felt that there was a comparable level of detail retrieval. However, of course, plugging the R26 into the back of the R27HE and switching between the analog input from the Gustard and the digital input from the inbuilt DAC, I could A/B easily between both of them, and the Audio GD came out a little bit warmer in terms of tuning, which is fairly typical for how Audio GD does things. Of course, on the other hand, the Schiit Yggdrasil, it has a slight wonkiness in the crosstalk, which means that sometimes there's a touch more mid-bass with some tracks. But overall, I kind of find it a little bit more on the kind of neutral and dry side. So it was fairly comparable with some music, but not necessarily with some others. But overall, if I was to give a 1 or 2 sentence summary of the Gustard's R26 detail and tuning, it was of a neutral sounding R2R DAC with a slight touch of maybe musicality in there, in that when I was listening, I felt good in listening with the R26 plugged in, whether it was into the ALO Audio Studio 6 or the Master 9 or whatever I had on hand, including an GSX Mini. But one other factor I haven't got into yet is what I call the audio rabbit hole, and this is changing the inputs and comparing the performance. One of the things I like to do is plug in a DAC directly into my Mac Mini Roon server and compare that to using the other inputs with higher quality transport, such as the ones I have here, including a Singsar SU1 and a HiFi Neo Stream. So the USB input, the overall sound was a little bit kind of dull and flat. But if I switched up to Gustard's own network streamer, plugging into my network, things improved a bit, and I felt that the sound, and I know it's one of those audiophile terms, more musical, in that individual notes and instruments were more distinct and more clear and more jumped out from the music to me. Likewise, I went then to the I2S input from both the Singsar SU1 and the Neo Stream. Now the problem with Gustard is they have their own particular pinout for I2S. It's similar to what other manufacturers have, but the channels are reversed. It wasn't such a problem with the Neo Stream because I could simply just unplug the regular outputs from the R26 into my amp and just reverse them. But with the SU1, I could actually switch it to Gustard settings so it would work perfectly. And then again, there was a little bit more improvement over the inbuilt network streamer. Now, I was thinking about this and what could be the reason. Now, I've experimented a lot with noise reduction in my system overall, and my conjecture is it mainly comes down to how much noise gets into the DAC, and the Gustard must, to some degree, be susceptible to noise such that it affects the analog output. Now, I can't test this absolutely, I can only kind of test with my ears what the output is, but these were my experiences. So I did a little bit of an experiment which some people have done with other DACs and probably even maybe the Gustard as well. Now I happen to be in the process of organizing putting an optical cable from the second floor of my house down to the first floor to connect the networks up rather than trying to set up a mesh wireless network. And doing so, I bought a couple of these 10G Tech converters which convert normal networking to optical networking. And I'm going to plug those in and then put the optical cable through my wall. But I thought it might be a good opportunity to experiment and see if that changed the quality of the network input on the Gustard. Now, I've also got the HiFi Neo Stream in for review, and that has an OptiBox, which does the same thing as this. It converts a regular network connection into an optical one, which then goes into the back of the Neo Stream. Now, as I was testing the Neo Stream, I thought I'd test it with the Gustard. And one of the things you can actually do is you can unplug the network for a couple of seconds and plug it back in, and you won't get any dropouts while playing back music. So I did this, switching in and out the OptiBox to see if it made any difference. And I felt that with the OptiBox, the sound was improved, much as I described before, where I could hear music came out kind of more clearly, basically, and more lively. So trying that with a 10G Tech setup directly into the Gustard's network setup as well, well, what I also did is I used an HiFi power supply to the 10G Tech on the DAC side so that if there was any noise coming through from the power supplies, it would hopefully be eliminated. And I noticed maybe a small improvement, not as much as the OptiBox had on the Neo Stream, which was interesting. But it was a nice experiment altogether, which suggests that the Gustard can be improved slightly if you do go at least use the inbuilt network streamer for good results. USB, maybe if you have an isolator, I didn't play around with that, but a good quality transport of some kind can definitely help. Now, here's a funny one. Now, if I want to eliminate all noise on the inputs, the best thing to use is straight Toslink optical, and I did that. And it was much like my experience with Chords Hugo 2, the sound quality was as good using optical input as it was using all these fancy components to eliminate noise and improve the input as well. So if you want the cheapest and simplest option, use optical. However, what if you want to do something like try upsampling to the DAC? Well, optical is limited to 192K, and a lot of people want to maybe upsample to, say, 384 or 768, or do basically high quality upsampling, or upsampling to DSD, so you're bypassing the inbuilt PCM ladder inside the R26 and using the DSD ladder. So I thought I'd try that. And experimenting around with HQ Player and Roon, I felt that the upsampling to, say, PCM 384 or 768 didn't really improve things over the inbuilt digital filters which we've seen that the Gustard has. DSD was maybe a very touch kind of more softer and euphonic, much like my experience with the R27HE. It did maybe change things a little bit. For some things like the bass, maybe the dynamics were slightly affected in a negative way, but for people, say, listening to, say, jazz or maybe a lot of acoustic music, they may find the soft, slightly more gentle presentation to be nicer in some regards. So if you want to go down that rabbit hole, then you may well want to consider the quality of the input into the back, but otherwise the network streamer did fine in terms of receiving DSD 512 or high-res PCM. But overall, if you just want to buy a DAC around the $1,500 price mark, and of course this goes on sale in various places sometimes, so do keep an eye out for that, it's definitely a solid entry in that price range. I definitely recommend it, especially if you want a network DAC and you're going to use something like Roon or DLNA, or one of those options where you want to stream to it rather than connect it directly to a computer. If you do directly connect it to a computer, you're not going to do anything fancy. Optical is actually the best input, which may surprise a lot of people who have dumped a lot of money into expensive external stuff. Let's not go down that discussion. The only thing I didn't try was something other people have tried, which is external clocks. Now that's a rabbit hole I refuse to go down because I'd have to spend big money. You know, there are clocks costing hundreds of dollars, thousands of dollars, and I think if you're spending thousands of dollars on a clock for a $1,500 DAC, no, that's maybe going a little bit overkill. I would spend the money on something like a Rockner, maybe. Maybe if you look on the places like HiFi, people have discussed that their own experiences with using an external clock, and they feel that it made an improvement. You can check that out yourself if you're interested in going down that rabbit hole. I rather talk about how the Gustard is on its own, and I reckon that as a DAC, it does pretty fantastically. And I really did enjoy listening with it. You know, I could plug it in, say plug it into the Studio 6 and enjoy listening, even though I do have much better gear here. It just gives a degree of enjoyment, which I prefer over regular Sigma Delta DACs. So before you go, do you have one of these? If you do, consider writing your impressions in the comments. These videos are designed to help people decide whether to buy or not to buy a particular product, and feedback from other users will help a lot as well. If you do decide to buy one, consider buying through the links in the description. Lastly, thank you to all my patrons who have supported this video. If you'd like my buying advice, you'd like to see my impressions of gear in advance, we have a private chat with a lot of great people where we discuss and help each other out with audio gear. Do consider becoming a patron, or if you'd like to just say thanks, you can click on the thanks button or buy me a coffee. The links are below the video, or tap on the relevant button on your mobile if you're watching through your phone. So as always, thanks once again for watching, and I'll see you online.